Hello, everyone, and welcome to the latest D-Zone webinar. Thank you for joining us live in the Research Triangle Park here in beautiful North Carolina. My name is Jason Cockrum, and I am the Community Engagement Manager here at D-Zone. And we're really excited that you've joined us today. We've got a very exciting and a really relevant topic for all developers, and so we're glad that you've joined us. If you're new to D-Zone, we are one of the world's largest online communities of software developers and experts. We publish all sorts of knowledge resources for developers and really anyone passionate about software development. We've got all kinds of stuff like ref cards and trend reports and thousands of articles written and published by our community. And all this makes us the go-to knowledge hub for software developers all over the world. We also do a ton of great events like this one today, and you can find them all at dzone.com/events. We've got webinars, we've got live webinars, on-demand webinars, fireside chats, virtual roundtables, and who knows, you might even see us in person at some events later this year. So be sure to check out dzone.com/events for all that information. Today, we are asking the question, how can we improve our database performance at scale? Being able to scale our critical databases quickly and seamlessly is a must-have for any business in this modern digital business environment. And a lot of companies are moving from technologies like MySQL to more efficient tools like Singlestore to help achieve this faster performance at scale. The most important part of migrating to these new technologies is avoiding downtime in the process. As we all know, any downtime during migrations can negatively impact our business. So we need to ensure that we can accomplish this migration without hurting the business. And that's what our guests are going to talk about today. In just a moment, I'm going to hand things off to Manish Kumar from Singlestore. Then he, along with Rajkumar Sen of Archeon and Franco Giglio of Publica, are going to share with us how all of this is possible. D-Zone is all about community, so we encourage you to get involved and to get engaged in the conversation. On the right-hand side of your screen, there's a box where you can chat with other attendees and talk about what's being discussed here today. There's also a box where you can submit questions to our guests, and they'll do our best to answer as many of them as they can towards the end. Be sure to follow all our guests, Archeon Labs and Singlestore on Twitter and LinkedIn, using the hashtags you see on your screen there. And this session is also being recorded, so don't worry, you'll be able to get a copy of it if you have to miss out today. And again, at the end, there'll be a chance where you can follow up with our presenters and ask any further questions or connect with them offline to answer any more questions you might have. So at this point, I'm going to stop talking and hand things over to Manish. Manish, take it away.
Thanks, Matt. Hey everyone, I'm Manish Kumar. I'm a product manager here at Singlestore with over a decade experience in database technology, both as a developer and a product manager. Currently, I focus on migration of databases into Singlestore and the security of our infrastructure. In the capacity as a migration product manager, I'm helping customers to either migrate, augment, and optimize their databases as they come to Singlestore. Raj, you want to go next?
Hi, everybody. This is Rajkumar Sen. I'm the founder and the CTO at Archeon Labs. Prior to starting the company, I spent more than a decade working at enterprise database companies like Oracle, Sybase, SAP, and my last database job was at a company called Singlestore. So I'm very proud of our partnership that we have developed over the past few years. Archeon started a few years back with the idea of connecting databases in real time. We provide a product which uses a technique called change data capture to replicate databases across cloud, across on-prem. And I'm very thankful to Franco and Manish and everybody else for giving this opportunity to showcase the product to that end of the session. Thank you.
Hi everyone. Yeah, I'm Franco Giglio from Publica. I'm the co-founder and CTO of the company. We have been in business for a little bit more than 6 years now. And in Publica, we empower publishers from literally all over the world to have their own e-commerce, but with a very, very, very flexible business model. They can do basically whatever they want. And our main idea behind it is to allow them to have very tight and true relationships with their own customers, with their own audiences, with their readers. We are a fully remote company. We have more than 1,000 stores and are powering giving service to more than 1 million active users each and every month. This is a little bit of our database journey. I'm very excited to share it. So what basically where do we started, or what are the challenges that we had previous to working on this? As any startup or any constantly growing startup, we faced many technical challenges. Some of this you may be familiar with, like scaling users search, like natural language search, also scaling analytics workload. Even if you use a third-party analytics tool, you you reach a point you need your own data and you need to query it in very specific ways, and it can be challenging doing that at scale. But also it's just like overall database scalability and low predictability, and also cost predictability. Of course, the idea is to not have to run a database or cluster many times bigger than what you need to be able to handle spikes. But at the same time, we are a very, very small team, and we don't want a DBA. We don't have a DBA, at least right now, and we don't have it. We didn't have it last year, when we did this migration. So these are like some of the things that we were considering and some of the challenges that we had at the time. And when we started the last chapter of our database journey, we were especially working on scaling users search. We work with digital content. That content starts its life as a PDF or EPUB or an audiobook, and we process it in many different ways. We extract all the data and we index it so users can find relevant content according to what they need. And the solution that we developed internally at the beginning, it wasn't really working. We had many millions of pages indexed, and it constantly crashed. Our queries could took anything from like 5 seconds to sometimes 30 seconds or even more. So it basically timed out, and the experience was, in many cases, terrible. And what is worse is that this affected our most important customers, because those are the ones that have the bigger amount of content. So we started looking for alternatives, right? Like the classic ones: Elasticsearch, Algolia, AWS OpenSearch. But we also consider other options like just like testing Aurora serverless. We were previously running search on a Postgre database, just because when we started working on it, MySQL didn't have full text search. And we also considering just like putting more money on AWS and having a bigger instance or a cluster. But it just wasn't enough. We have other requirements, so just like things that we wanted to achieve, like real-time search, like very, 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 very fast and high-quality searches. Also real-time analytics, of course. We wanted it to be MySQL compliant, though we thought that was like almost impossible. Having a single database platform was appealing, but I think what was a little bit more powerful was just like we didn't want it to just like add more and more and more technologies. Again, a small team, mostly MySQL expertise. And another thing was it was just something that we didn't wanted to. We of course wanted very, very, very good performance and a reasonable pricing. It feels like it's something that you will have a very, very, very hard time finding, and it doesn't have to be that way, thankfully. So by almost pure chance, someone I know recommended that we take a look at Singlestore because they provided full text search, which is, at least at that time, the most important thing for us. It was the most important thing for us. But when we started looking at it and testing it, which took like, I don't know, minutes, it was very easy to use, or just to spin up a test cluster with free credits they provide. We saw that search performance was, it was basically exactly what we needed. We could do anything that we were doing at that time, but it was much faster. Like searches to the slowest ones, like 300 milliseconds. And that's without optimizing absolutely anything. We just migrated one thing to the other and it worked. Which was a little bit surprising. But it doesn't really stop there, and we are now taking advantage of some of the things that you can see in the slide, like real-time ingest, Singlestore. It doesn't really care if you are importing, like if you are taking like 1 row per minute or per second or millions of rows per second. It can handle it without any issue. At the same time that you are ingesting all the data, you can query that data in real time without slowing it like at all. You can process tables with millions, billions, or trillions of rows while you are inserting data, and all those queries can take like less than a second. So it's a really flexible and powerful system that I think one of the key features for us is that it gives you peace of mind, and I will talk about that in a bit. And something that we really, we wanted it, but we didn't really know it was actually possible, is that it is an hybrid database. It's not just about transactional workloads or analytical workloads or other workloads like cache or search, for example, but you can do everything in the same platform, in the same cluster, on the same data at once, at the same time. So you don't need to move data from one platform to another, from one server to another, cluster to another. You don't need to worry about anything like that. You just have your data, your source of truth, and you can work on that data in different ways without needing to worry about, is this particular technology capable of, analyzing billions of rows while we aggregate the data, or while we look for very specific rows because we need to show something to a particular user. And that was amazing for us. We didn't know that existed. And we basically had a lot of success with our migration and with our technology choice. Search results are, in some cases, 70 times faster. Overall, our app gain speed up of 35%. Some pages are much faster, and some are a little bit faster, but 35% overall, it was incredible for us. We also saw a 30% overall cost of ownership decrease over all the databases that we were operating before. And the one that we were actually most excited about in the mid and long term, it's about the productivity increases, because now our teams just need to worry about one data platform, which is our source of truth, and we can do anything on that data, and we don't really need to worry about learning new things or new ways to communicating with that data. If we were to choose Algolia or Elasticsearch or any other solution, of course, we will have to do that. And at the same time, we don't need to babysit our database, and we can do new things. We can basically move way faster. We don't need to worry about, is the database going to be okay with this? Should we? We just spend much less time testing it and profiling it, because it usually just works. But again, this is about our migration journey too, and this was not the first time that we did a big migration, like a very important and critical migration. We had been in different clouds. We basically started on AWS, then migrated to Google Cloud, then back to AWS, and while we are now on AWS, we are also using Singlestore. So we migrated our database many times, or our databases, because we used to have many. In the previous migrations, we just basically employ a very very simple and trustworthy dump and load strategy. We extracted all the data and just like imported it into a new database. Of course, that's slow. It can work if your data set is like really small, or if you can afford downtime. But this time it was completely different. We couldn't really afford downtime. Maybe a minute, but we were not talking about minutes, but hours. But we had at the same time like 25 times more data, maybe even more. We needed to ensure correctness. At the same time, we needed it to be fast. And while Singlestore has many different ways that you can just like put data into it, one of course is the MySQL compliant API protocol, but you have other options like CSV and Parquet imports and exports too, using a tool called Pipelines, which is very complex but very powerful and extremely fast. The thing is that we needed to migrate multiple databases with a lot of tables, and that data was changing like in real time constantly. So it was just too complex for us. So these were basically our options, right? We could invest, considering that we didn't want to have downtime, but we could invest many months into just like figuring out the way to make our app work with both data stores at the same time while we migrated everything in the background, like asynchronously, some way. Thankfully, we didn't do that. We could also take down the platform for 6 hours, about 6 hours. That was like our very broad estimate, but of course that was completely unacceptable. We could outsource it to a professional that just like knows everything about these things. And again, maybe that will also include downtime or something like that. We didn't really know. But what we did know is that that was going to be very expensive. So it wasn't really like a viable option for us. But at the same time, we will need to basically just like ideate and probably also implement in code and different services a lot of checks just to make sure that the migration was successful and that all the data that we needed to migrate was migrated. So to have basically data correctness. But at the same time, and this is something that was like very important for us. Again, we couldn't have downtime. Right? It was a very, 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 very thing for us. And of course, if you have downtime, or you're not going to be real time. I mean, you have to take down the platform to be able to do the migration, and you have to pause everything. So I'm basically talking about people that want to buy something and then read it or listen it, and we will basically be preventing that. But also, we wouldn't have any like information about how the migration was going, or the information would have been very simple. Like, okay, I am migrating 100 gigabytes, and it's on 30%. But what tables are already migrated? There's a lot of things that we wouldn't have known. Thankfully, I attended a webinar that guys from Singlestore and Archeon hosted. Almost, I think that was like 10 months ago, something like that. And if I remember correctly, Rush was actually there, and he showed something that he's going to show today again. So you will be able to see it, but I was extremely surprised. I didn't really know that a tool like this existed. Archeon it's a cloud-native CDC platform. I didn't really know what CDC even means, but it's about change data capture, which basically means that the way that Archeon gets a hold on your data, on your source data, it's by logs on the database. So it's not really impacting the workload and the performance of your database or of your cluster. So you don't really need to worry about like having severe slowdowns or anything like that. it will just use all the resources available on that cluster to move the data as fast as possible. But you're not going to see any real impact on the production and real-time workloads on that database. It is very, very, very low latency in the time it takes to move data from one place to another and to validate that that the data is correctly migrated, and it can guarantee that correctness. And something that is still today very important for us is that it's super simple to use. It's very, very, very easy to use and gives you a lot of information, so it's like at a glance. You can set it up in minutes. There are a couple of options that you can choose, of course. You can use your own servers. You can host it yourself. Maybe that's useful if you have a very, very large amount of data that you need to migrate. I assume that's going to be like a more cost-efficient option, maybe. Or if you have sensitive information. But you can also just choose the cloud and go with the managed service. If you do that, you get many advantages. That for us, those advantages were very important. We didn't need to worry about servers. We didn't need to worry about just like learning how to host and manage and scale Archeon. We could let the pros do that, the people that actually like invented it and are working on it. So that was super appealing for us. And I clicked the trial button like in, I don't know, like 5 seconds. This is a very quick summary of how you set up the migration. Again, we're going to see Rush show this in a bit. But each migration, which is actually called a replication in Archeon, still to this day I still say migration. But it was like why we did it, right? You can choose a snapshot replication mode or a full replication mode. And a snapshot is just going to be like a one-time thing. It basically takes all the data in one place and replicates it in another place. And you have many options on source and destinations. I'm going to show you that in a bit. Or you will also do a full replication, which will start with a snapshot. And when the snapshot is finished, so when you basically have the same data in the source and in the destination, the same data that you started with, it then transitions into change data capture, and it transitions into what is basically a real-time replication. So it makes sure that both data stores are in sync. For us, that was like almost magic. It sounds like I am maybe a little bit hyping it, but I'm being completely honest. And yeah, we were really, really hyped about it. You can also choose, or you should choose, a write mode. Default is replacing, which just basically it takes the source, replicates it into the destination. But when it does that, it just starts from scratch, which I imagine it's we actually use that. We actually use that in a couple of databases, because remember, we had like 5 or 6 different databases, which feels super weird because we now just worry about one. But you can also choose truncating, which is what we use for our most important and mission critical database. When you choose truncating, the advantage that you have is that you preserve the schema on the destination database. So basically what this means, or why it was useful for us, again, we were migrating, at least most of our migrations were from MySQL and Postgre, and the bigger ones from MySQL, to Singlestore. And while Singlestore is MySQL protocol compliant, and most of the time you can just copy one schema and just use it in Singlestore basically, and it just works. You are able to fine-tune it with Singlestore specific parameters. Of course. And for some of our tables and for some of our workloads, we saw that just by doing some slight tweaks, we could improve performance like by many times. So and that was a little bit surprising too. Like Singlestore was already most of the time as fast or faster or way faster than MySQL, but with just a little like very small tweaks. I mean, we are not much more proficient with it, but at that time we knew very little. With just small tweaks, you could achieve much better performance. And for some specific parts of our platform, we wanted that. We wanted to be able to take that opportunity to also improve performance and improve the user experience of all the administrators and readers using our platform. So we choose truncating. We handcrafted the schema. We basically created that schema, created the database and the tables in Singlestore, and we choose the truncating write mode so that the schema was preserved, but Archeon could take care of just migrating all the data. And this you get this dashboard, which was I mean, it was very, very, very useful for us because, again, the last migration that we did, we were actually like very excited that we had used a CLI command that gave us the overall percentage and speed of the data migration. And we were actually like kind of happy with that. This time with Archeon, we got a lot more information. You have the basic things like a loaded login, but you also have error logging. So while you are testing it and doing basically dry run migrations, you're probably going to find some errors, especially when setting up your source database. For example, if your source database is a MySQL RDS, you're probably going to have to enable a couple of parameters. It's on the documentation. It is very, 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 very simple, but you are probably very excited and want to try it like very, very quickly, and you're going to run into that. So you get the errors that tells you, hey, you should check this out. So that was useful for us. But you also have BTL monitoring and statistics. I'm going to show you a little bit more of that in a bit. And of course, like the overall like health of the replication. And that's where you can also see when the replication switches into the real-time mode, which fits a little bit magical. I don't know if you can read the numbers and the text on that screenshot, but that's from like our like real production migration, and that's from our critical database, the one that had the most data. And basically what you can see is that it gives you information on a per table basis, and it tells you the amount of data that it replicated from one place to another in the snapshot mode. But it also tells you if it had then in real-time mode had to delete information at rows, update rows, or replace it with other rows. And you also have information about the speed that is doing it. What we did to basically feel comfortable about doing this, because again, this was our production migration, our production database, and we were moving it from one place to another. We of course prioritize the different databases that we had, and we started getting familiar with the tool and with Singlestore. First with the staging and non-production databases, and the ones that we could maybe have like 15 minutes of runtime, and it wasn't an issue. So thankfully we have some of those databases. So we learned to use Archeon doing those migrations, and while doing that, we designed a very robust, like approximately 50 or 50 something steps, like a checklist of everything that we needed to do to make sure that everything works correctly. That checklist included things like going to Archeon and setting up the migration. That was basically one item. Like firing up the migration, that was another item. So I'm saying this just so that maybe 50 steps sounds like a lot. In reality, most of those steps were really like extremely simple and just like 2 clicks. And at the same time, it gave us a lot of like peace and confidence because we knew exactly what we needed to do. We have a use case, a case study on Archeon's blog, and in that case study, we share like 11 very general steps that you should take to do a migration like ours. It's a very, very, very simple thing. But yeah, we went a little bit, maybe a little bit over because we wanted to be completely sure. And the migration was a huge success. It was super simple to accomplish, and the results were amazing. I was actually like so excited that I just like of course I did what tech people do, which is like to tweet everything. So I just tweeted about it, and what surprised us the most, I think it was, well, it's a lot of things, but we migrated millions of rows in just like minutes, and that's on the slow side for what Archeon and Singlestore can do. We were maybe in a, like, again, this is, I think that's like the slowest that it can go, because our data centers were in different places, like very far apart geographically. So if you are moving data inside the same data center, that's like 2 or 3 or 5 times faster. It's really impressive. And it really blow our minds. And the thing that surprised us, I think it was both things, like the speed of it and the simplicity. But at the same time, when it switches to real-time mode, one database is maybe 1 second behind the other, like less than a second on most cases. So you're basically working in real time. And when you finish the migration, it switches to real-time mode or finish the replication. We basically deploy the new version of our app that switches the database that was used, and we just in that instance instant we connected to Singlestore. We just like stopped using MySQL and I started using Singlestore. It's just like that. And it wouldn't have been possible without Archeon. So I think I said it many times, but we were extremely surprised. At the end, some of the like highlights of our migration, we estimated we'd save more than 4 weeks of development work and planning and a lot of headaches and possible also a lot of downtime. The lag between the databases, again, it was actually less than a second between the databases and between the different tables of the databases, which just gives you peace of mind, because at the same time, while you have that very, very, very fast replication and very like slow lag between the databases, at the same time, Archeon is validating that you have consistency and that everything that is on one place, it's also in another, or everything that gets deleted on the source, it's also deleted or updated or whatever in the destination database. So it's not just, okay, we got 1 second delay. It's, okay, we have 2 exact replicas and you only have 1 second of delay, like at most. We migrated around 400 million rows. That's without counting all the tests that we did. And for our critical database, we averaged around 4.5 rows a second. Again, that was on the slow side because we were migrating clusters in different data centers, but it can be much faster than that. It's not the only thing that Archeon can do. You can use it for many other things, and it's actually a tool that we consider that it's now on our tool belt. You can do real-time analytics and reporting, just migrating from like one place to another, which is similar to what we did. You can also do it bi-directional. You can use it to do distribution of data to many targets, one place to many, or you can also use it to consolidate many data sources into one centralized location. And of course, as I told you, and this list keeps growing and growing and growing. But right now, you have a lot of options to connect different databases using Archeon. There are many different options that you can use as a source, not just MySQL and Postgre, like in our case. And also, you have many different targets. As far as I understand, Singlestore is the fastest to ingest data. So that may be something that you want to take a look at. But still, there are many options. It's a very flexible, powerful and flexible tool. So, well, this is it's a very high level summary of our migration and our database history so far. And I would like to now hand it on to Manish, because he's going to tell you a little bit of what Singlestore has in its roadmap, and there are very exciting and impressive things.
Sure, Franco, thanks. And it was a great journey that you just explained in 30 minutes. I would love to understand, like, since you have moved into Singlestore, how have you benefited from some of the innovation that Singlestore has done around either the JSON improvement or a lot of improvements on the vector functions that can be useful for your AI, or just in general, any new analytical use cases that you have been able to explore after moving to Singlestore?
Yeah, sure. Well, actually, I mean, I could speak like another hour about this. But yeah, we had some very specific analytical needs when migrating to Singlestore, and the performance different with those it was fantastic. And I think that was the place where we see the most performance difference. But the new improvements on JSON 6, those are something that we were excited when it launched, but that we could start using it actually a couple of months ago. We implemented a very simple log that just like logs data in JSON, and we insert millions and millions and millions of rows constantly, which is something that we will both have a hard time doing with MySQL, because we also query it constantly. So yeah, we don't really need to worry about that. And now the JSON searches that we do inside the data are also like extremely fast. That was a bit surprise. The other things that we are like extremely excited about, and I know that you have many things like this in roadmap, but just with all the different things that the AI scene is like giving us, and all the hype that is around it, to be able to just like use our own database without the need to just like add many other external tools or learn other external tools, to be able to use these new powerful AI systems like the ones from OpenAI directly on our data. That we think that's amazing, and we are very excited to work on a few. I feel that if we call it features, we are basically like underestimating it. But we're very excited to work on new features and experiences around AI, which are actually like possible because of you guys. So yeah, coming in the next weeks from us. But at the same time, there are other things that we find very impressive, and maybe some of the things that we are not, at least us, currently taking advantage of. But still, you recently released this thing about the disk spilling, which it basically allows us to like, and I know that I said this like many times already, but not have to worry about and don't have to babysit the database like anymore, because even if our data set gets gigantic, And for us, it's already very big. Even if it keeps growing and growing and growing and growing, and we query it in more and more complex ways, like constantly, we don't need to worry about our cluster getting hugged or the RAM of our cluster getting basically we're running out of RAM and queries not completing or anything like that, because that workload will just like spill to the disk. It will run a little bit slower, but it will finish and it won't fail. And that's something that we didn't know it was possible, and that's amazing.
That's actually amazing. One of the things that you touched upon was the new AI applications that
Oh
Singlestore
yeah.
has helped you build, right? And I just want to make sure that we are going to do a couple of webinars towards mid and end of this month. The links for the registration will be part of the subsequent emails that we send to the registrants. But we are super excited to do some cool innovation with the entire Chat GPT-4 movement that has happened, and how can Singlestore be at the center of it? Uh, but thanks for sharing those information, Franco. With that, I wanted to bring in Raj because while all these stories add real value, it's even more exciting to see this in action. So over to you, Raj.
Thank you, Franco. Thanks for the amazing talk, and Manish, thanks for helping us with the connecting dots. So I will not take much time because we want to give some time for Q&A. So I'm going to share my screen and start the demo here. So on my screen, I have Archeon Cloud, as Franco mentioned. Archeon has two products. The first one is something that you can host in your own environment. In this case, we are showcasing today Archeon Cloud, which was the product Franco used to do the zero downtime migration from MySQL to Singlestore. Today, I'm going to demonstrate a small data set in the interest of time, but we'll go over all the steps here. So if you log into Archeon Cloud, which is a fully managed cloud service to do CDC end-to-end database replication, this is what you get. If you have a few replications that you have created in the past, you would get all this information when you get in. In this case, as you can see, I have a draft thing which I have stopped, and I had you could put a name, you could get the source, target, and all of that. So what I'm going to go today is to do a new one, and this is the screen that you get. It's pretty easy. With a few clicks, I'm going to show that you can just get something moving pretty fast. So you give a name for this. So we are going to give this day demo April 6th or something. So once you give a name, you got to select the mode. I think Franco touched on it. The snapshot mode is something that you copy data one time. Full is the whole zero downtime migration thing. And today I'm going to choose the replace mode, which is to recreate the schemas and tables again. There are other two modes in the product, which is truncate and append. Most of these are available in our documentation also. So I'm going ahead with the full mode today, which is the initial data load as well as the full replication, and then replace mode, which is to recreate the schemas and all of it. So the next thing we do in the pipeline is to select the source database. So I've already pre-populated some of the databases that I use, and I'm going to use this MySQL database, but I'm going to show you how to add a new source here, which is you can go and select MySQL as a source, and it's pretty easy. As you can see here, you got to give the connection name, host, username, password, SSL certificates, and a few other options. And the interesting part of the product is that the doc pages are directly linked here, so you can scroll all of this to figure out what you need to set in your source database for you to connect and get started. So what I'm going to do is I'm going to use a database that I've already created here, and I'm going to go to the next state, which is the target database. So what we have done so far, we have given a name for the pipeline, we have selected the modes, and then we have selected the source. And the next step is to select the target database here, which is, the Singlestore database here. So I've already populated the database here, and I will select this. Even on the target side, you can add your own target here, and I'll show you. If you select Singlestore here, then it's the same thing like I showed you for the source. You have put your database credentials and all of it, and everything that you need on the target side to be able to write. All of this stuff is, the doc page is linked here, so it's pretty easy to follow the steps and everything. So I go back. So I selected this, and I can continue to the next step, which is the filter. So the filter file is something that allows a user to select a subset of the total data. So let's say you have 5 schemas and you want to select a few schemas out of them, and let's say within the entire schema you want to filter out certain tables that you do not want to be as part of the replication. And let's say for a certain table you do not want a certain column out of the replication, so you can filter out things like that. So and then once you do that, as part of the filter, you can do a lot of advanced stuff in the product, which is to map tables and configs. So these are advanced parameters where you can change the name of the tables, change the name of the columns, and do some other transformations. So I will just do the basic stuff here today, and I will hit the start replication button here, and we'll wait for the next step here. So what is happening here is now, as I mentioned, it's a cloud service. So behind the scenes, it's grabbing, the set of hardware resources that we need to do the job. So it's starting the Dockers and all of that stuff. So this is the dashboard that Franco had mentioned, that we give a lot of information to the user on what's happening, right? The most important information is the source, target, and is the replication running and what you want to do. As you can see here, this is lightning fast thanks to a great product called Singlestore, where ingestion is super fast. As you can see here, we have already created the 7 tables within few seconds. We have written all the tables here, and we are actually in the change data capture phase, which means the initial data has been written, and the product is ready to listen to incoming new transactions. I will show you one thing, which is the details tab, where we can see per table information about insert, delete, updates, and other activities. And we have all the information in the main dashboard, along with the streaming of the actual trace log. So in this case, we don't have any errors, but in case you have errors, all of them are going to show up here, and you can also use this to debug and all of that stuff. So as you can see here, so far we have copied all the 7 tables, we've created them, removed all the data. It's in change data capture mode. So I'm going to use my SQL console, and I'm going to do an update query on the orders table here, and I'm going to update a row here, a few rows here. So let's hit this and see what happens on the so we have done this update on the orders table. So what's going to happen now is that the code here is going to wait for the log to show up, and as you can see here, the changes were pretty instant. So we did 255 rows update here, and all those changes were picked up almost within a few seconds by the product, and it was delivered to the target. And if we go to the details tab here, this information is also mentioned here. So in a nutshell, I gave a demonstration to you of what Franco mentioned, that the product is super real time in combination with Singlestore. I think the combination works like magic. We were able to move data instantaneously, and not only move the initial data, we were able to do a few updates, and in all of that move to Singlestore instantly. So you can do things here, like you can stop the pipeline and all of that, and you can resume pipeline. So we have all of those features as part of the SaaS offering. With that, I will conclude my demo, and I will stop sharing, and we will open up for the next set of questions. And thank you.
Awesome. Thank you, Franco, Manish, and Raj, for the excellent presentation and demo. We're now going to begin the live Q&A portion of today's session. So just as a reminder for our audience, we'd love you to participate. Just check out that Q&A functionality on your console. And if possible, please just let me know if question is for a specific panelist or just for everyone, that'll help me. But we already have some questions in the queue here, so I'll get going. This one's for Franco. It's from Christopher. You mentioned during your presentation that there are some overall cost decreases. Is that strictly infrastructure, or are there other things that you factored into that reduction?
That is strictly infrastructure. Yeah.
Got it. Cool. I think this is probably another one for you, Franco, or Manish. You might chime in, but it's with high ingestion. Have you had to do anything to address deadlocks? Have you found that you just don't have them due to the increased speed, or did you do anything specific to reduce the chances of that occurrence?
Yeah, I'm sure Manish can give you much more details, but at least from our side, we didn't have to worry about it like ever.
Yeah, and typically that's the same experience we have seen. Customers using Archeon or even our native ingestion technologies typically don't hit deadlocks. We try to fix that natively in the engine itself.
Awesome. This is a follow-up to that, and maybe you already answered this, but what kind of tuning have you found that you needed to do after the migration?
Oh yeah, that's a great question actually, and we can get very deep in that question. But again, just to remember, we were migrating from MySQL, which is normally not a sharded database, Singlestore is. So the things that we needed to think about the most, and the ones that that help us see the most performance increases, is just like very deeply think about the shard columns and all the shard keys and the columns that we are going to shard on, and also the sort columns. Those were the most important things for us. Of course, Singlestore chooses a default that most of the time just works perfectly, but you can and you should fine tune it to your data and to your workloads.
Awesome. I think this one is for Raj. It's from Rakesh. It says there are multiple CDC-oriented replication tools for syncing data. How is Archeon different from a baseline Kafka-based replication?
So, a couple of things. We also support Kafka as a source and target. Archeon is an end-to-end replication that doesn't require installation of external queues like Kafka. So we have an in-house mem queue and an in-house solution which is packaged in the product. So Archeon by itself doesn't need Kafka in between. You could use Kafka to be as a serving layer, but Archeon is independent on its own. One product differentiation with Archeon and the previous vendors in this space is that Archeon is just like Singlestore, is very driven by parallelism and usage of memory. So if you throw more memory and more cores to Archeon, it can scale, and as well as exploit the memory given to it. So in a way, it is a more modern and cloud native product, which allows us to do replications as fast as we saw in the demo today. So those are the differences. And I would honestly think that right now we are the only true cloud CDC solution in the market today, pure play cloud CDC solution. So that gives you a flavor of how modern it is in the context of the legacy systems.
Great. Raj, we'll stay with you. This one's from Christopher. If the tables have foreign keys that are important for joins in the application, what does the migration look like then? Do I need to break all the foreign keys before being able to move, or what does migrating with foreign keys require?
That's a great question. It's a question that comes to us every day. So, Christopher, Archeon handles foreign keys. So we will identify the order in which we have to migrate the tables. So at times, migrating with foreign keys can delay data ingestion in certain platforms, not a thing, but in certain cases, it doesn't. So it depends on what target database you're moving to. We have options where we move the data and then enable the foreign keys. In certain cases, we move with the keys. So we have various options, and you don't have to drop anything. If Archeon is being used to move the data. This is assuming that the target system also allows you to add keys, right? So.
Got it. Okay. Another one. Can a new table be added to the replication job without restarting replication from the beginning?
Yes, excellent question. Yes, I showed you the filter file as part of the replication. So if you use the filter file and give hints to, there are options in the product where you could say all tables in the schema. If you select that option, then any new table that gets added gets automatically added in the pipeline. We are also adding new features where you could give like a regex pattern that matches new tables and all of that. But fundamentally, the product has infrastructure to figure out that new tables have been created and automatically gets added in the thing. And we also have options where if a table is dropped, then we figure that out and remove it from the replication also. So both create and drop. And for certain platforms, we actually even support truncate. We figure out that a table has been truncated. So we have support for a lot of DDLs essentially.
Awesome. Great. Another one. This one's from Rakesh again. Can Archeon show the type of transactions that the replication can choose? Example, ignore deletes.
We are adding that feature very soon. I think it has been a very it's something that we have been asked. So this is coming out. This feature is coming out either this month or in the mid-May release. So yeah.
Great. It seems Archeon is using MySQL bin log output to capture the changes that are happening in the database. This requires the replication serial. How do you plan to enable replication with large amounts of changes happening across multiple tables? We have 500,000 updates per bin log.
So So the architecture is pretty parallel inside Archeon's replicant. As you know, database log is serial in nature anyway, so you can't do anything there. But we read the serial bin log and we parallelize a lot of activities. We have actually had customers, on a few databases where even gone to reading with the right hardware, of course, more than 700,000 operations per second. So even though the database log is serial, we do a lot of things to get the data out and read it and extract it in parallel and do a lot of funky stuff. So I really appreciate we can get on a call and explain the architecture. I don't think we had the time in this webinar. Maybe we can showcase a webinar where we do all of this in parallel. But a great question actually, because the answer to that in an extended format actually would highlight the IP that we have developed in the product.
Awesome. I'll do one more before turning it back to Jason. Manish, can we use Archeon with Singlestore both as a source and as a destination? Example, to migrate from on-prem Singlestore to the cloud.
Yes, we can do that, provided we set up the right connectivity.
Good stuff. Jason, you want to take over to take us through the ending?
Sure, will do. Thanks, Matt. And thank you to Manish, Rajkumar, and Franco for sharing your insights with us. And thank you very much for everyone joining us today. And as you can see here, once again, there's ways you can connect with our guests. If you do have any further questions, be sure to follow up there and take advantage of some of the free trials and the offers you see on your screen there. So don't miss out on that. And lastly, once again, be sure to check out our website, dzone.com/events, for all of our other great events just like this one. We've got on-demand webinars, virtual roundtables, fireside chats, and like I said, maybe even some in-person events later this year. So be sure to check all of that out. Thank you, everyone, once again for joining us. Have a wonderful rest of your week, and we will see you all next time. Thank you so much.
Thanks a lot.
Thanks, everyone.
Thanks, everyone. Bye-bye.